Welcome. Today, we are diving into the world of traffic shaping and policing. These are essential techniques for managing network bandwidth and preventing congestion. It's all about making sure your network runs smoothly, even when things get busy. Traffic shaping is a method to control the amount and rate of traffic sent into a network. Think of it as a way to smooth out the flow of data. Traffic shaping delays packets to ensure they conform to a specific traffic profile. This means it controls the data transmission rate, buffers excess packets instead of dropping them, smooths traffic flow to prevent congestion, and ensures consistent quality of service. By using traffic shaping, you can prevent any one application from hogging all the bandwidth and ensure that important applications get the resources they need. Traffic policing is another technique used to manage network traffic, but it works a bit differently than traffic shaping. Traffic policing monitors and limits the rate of traffic. When the traffic exceeds a defined threshold, traffic policing drops or marks packets. This enforces maximum bandwidth limits. It does not include any buffering or queuing mechanisms. It is typically used at network boundaries to protect the network from excessive traffic. By policing the traffic, network administrators can ensure that no single user or application consumes more than their fair share of network resources. Traffic shaping and traffic policing are different approaches to managing network traffic. The main difference lies in how they handle excess traffic. Shaping buffers excess packets, introducing delay and jitter. It requires memory for buffering, smooths traffic flow, and is typically used at network egress points. Policing, on the other hand, drops or marks excess packets, introduces no additional delay, has minimal resource requirements, creates bursty traffic patterns, and is typically used at network ingress points. Both mechanisms can be used together in a network to achieve optimal traffic management. There are two main traffic management algorithms. First, we have the token bucket algorithm. It controls traffic by requiring tokens to transmit data, with tokens generated at a fixed rate. Tokens are added at a constant rate, the bucket has a maximum capacity, and it allows for controlled bursts. Second, the leaky bucket algorithm smooths traffic by processing packets at a constant rate, regardless of input rate. Packets exit at a constant rate, excess packets may be dropped, and it eliminates traffic bursts. Let's see how we can implement traffic shaping in Cisco IOS. First, we define a class map to match the traffic. We use the command classMap, followed by a name like matchVoIP. Then, we match a particular protocol like RTP. Next, we create a policy map with shaping using the command PolicyMap, followed by a name like shapePolicy. Then, we refer to the class map we defined. We shape the traffic to an average rate, for example, 1 million bits per second, 125,000 bytes, and 0 excess burst size. Finally, we apply the policy to an interface in the outbound direction using the command service policy output shape policy. Now let's look at implementing traffic policing in Cisco IOS. First, we define a class map just like with traffic shaping. We use the command classMap, followed by a name such as match HTTP. Then we match traffic based on a certain attribute such as protocol. Next, we create a policy map with policing. The command is PolicyMap and a name. Then we refer to the class map. We police the traffic to a rate. For example, 5 million bits per second and 8,000 bytes. If the traffic exceeds, we drop the packets. We apply the policy to the interface in the inbound direction using the command service policy input police policy. Traffic shaping and policing have many real-world applications. Traffic shaping is ideal for scenarios where maintaining a consistent traffic flow is critical, even if it means introducing some delay. Use cases include ensuring video conferencing quality by smoothing traffic, preventing wide-area network link saturation in branch offices, prioritizing critical business applications, and managing traffic at network egress points. Traffic policing is best suited for scenarios where strict bandwidth enforcement is required and excess traffic can be dropped. Use cases include enforcing service level agreements, limiting customer bandwidth in service provider networks, protecting critical infrastructure from denial of service attacks, and controlling traffic at network ingress points. Here is a summary of best practices and key considerations. For best practices, we should use shaping for outbound traffic management and policing for inbound traffic control. We should combine both techniques for comprehensive quality of service. Also, we should monitor the performance after implementation. For key considerations, we should assess application sensitivity to delay, calculate appropriate bandwidth limits, consider hardware resource requirements, and plan for traffic growth and scaling. Effective traffic management requires a balance between network performance, application requirements, and available bandwidth. Regular monitoring and adjustments are essential for maintaining optimal network conditions. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.